For centuries, sailors have crossed every ocean on Earth believing that the largest animals ever to exist would eventually appear wherever the waters were deep enough and food was abundant. Yet there is one vast region of the sea where even the biggest whales on the planet almost never go, not because it is shallow and not because it lacks space, but because something about it repels life at the highest level. This is not a legend, and it is not a myth created by early explorers trying to explain strange routes on old maps, because modern satellite tracking shows the same pattern again and again, with blue whales, fin whales, and sperm whales altering their paths as they approach this area, then slowly turning away as if an invisible boundary had been crossed. What makes this detail unsettling is that whales are not fragile animals avoiding minor discomfort, since they regularly dive into crushing pressure, pitch-black depths, and freezing temperatures that would kill most creatures almost instantly, which raises an obvious question that oceanographers struggled with for decades. What kind of place could exist in the open ocean, far from land and storms, that is so inhospitable that even animals weighing more than 100 tons seem to instinctively avoid it? At first glance, this region appears completely ordinary, with no towering waves, no violent currents, and no obvious signs of danger visible from the surface, which is precisely why it remained unnoticed for so long, hiding in plain sight on global shipping routes and satellite images. Yet when researchers began overlaying whale migration data with chemical readings, depth profiles, and acoustic measurements, an eerie pattern emerged, suggesting that the ocean itself behaves differently there, not violently but subtly, in a way that interferes with how large animals survive, communicate, and navigate. This is not a place where whales are hunted, trapped, or driven away by noise alone, but rather a zone where the basic rules that normally allow massive marine life to thrive seem slightly broken, just enough to make staying there a biological gamble. And the most disturbing part is that this region is not small, not remote, and not shrinking, because it spans thousands of square kilometers, sitting quietly in the middle of the ocean, avoided not just by whales, but by nearly everything at the top of the marine food chain. Despite their massive bodies, whales live in a world dominated by sound, chemistry, and energy efficiency, where survival depends on long-distance communication, precise navigation, and an uninterrupted flow of oxygen and food through systems that are finely balanced, not indestructible. Whales do not see the ocean the way humans do, because vision becomes unreliable very quickly underwater, especially at depth, so they rely on sound to orient themselves, locate food, maintain social bonds, and even synchronize migrations across entire ocean basins. Low-frequency sound, in particular, travels extraordinarily far in water, sometimes crossing hundreds or even thousands of kilometers, which allows whales to build a kind of acoustic map of their environment, sensing distant coastlines, seamounts, and other animals long before they physically arrive. At the same time, their immense size creates a problem that smaller animals never face, because moving a body that large requires a constant balance between energy intake and energy loss, meaning whales must spend most of their lives in regions where food density, water temperature, and oxygen levels align almost perfectly. A small disruption that would barely register for a fish can become a serious threat for an animal that must consume tons of food and process enormous volumes of oxygen just to survive day after day. What makes this especially important is that whales cannot simply stop and rest if conditions deteriorate, since lingering in an unsuitable area can drain energy reserves faster than they can be replenished, turning a short delay into a potentially fatal mistake. This is why whale migrations are not random or exploratory, but conservative and precise, shaped by generations of evolutionary memory that favors routes known to be stable, predictable, and biologically efficient. So when multiple species independently alter their paths to avoid the same region, scientists take notice because it suggests that something fundamental about that part of the ocean interferes with the systems whales rely on most, not through sudden danger, but through persistent, invisible stress. If you enjoy understanding how science explains deep-sea things, subscribing to the channel is a simple way to keep this kind of stories coming, because every video here follows the same careful of observation, evidence, and clear explanation. As researchers looked more closely at the regions whales consistently avoided, they began to notice that these areas shared a strange physical characteristic, one that is easy to overlook because it does not involve storms, predators, or dramatic geological features. In these zones, the ocean behaves less like a single connected body of water and more like a layered system that refuses to mix, creating invisible barriers between surface water and the depths below. Under normal conditions, wind, temperature differences, and currents help circulate nutrients and oxygen throughout the water column, allowing life to flourish from microscopic plankton to massive predators. But in certain parts of the ocean, this vertical circulation slows down dramatically or almost stops. When that happens, oxygen-rich surface water fails to reach deeper layers, while nutrient-rich deep water never rises to the surface, breaking the exchange that supports complex ecosystems. To a satellite image, these regions look completely unremarkable, yet chemically they are very different, often marked by unusually low oxygen levels below the surface, creating what scientists call oxygen minimum zones. For smaller organisms, this can mean stress or reduced growth, but for large animals like whales, it introduces a more serious problem, because their prey begins to disappear not suddenly but gradually, thinning out over vast distances. At the same time, these layered waters interfere with how sound travels, bending and scattering low-frequency calls in unpredictable ways, which can disrupt communication and navigation for animals that depend on acoustic cues to survive. What makes this especially dangerous is that none of these changes announce themselves clearly, because there is no sharp boundary, no visible line where conditions abruptly worsen, only a slow degradation that whales seem able to detect long before humans realized it was happening. As a result, whales approaching these zones are faced with an environment that feels biologically inefficient, acoustically confusing, and energetically costly, even though nothing appears overtly hostile. For years, this explanation seemed sufficient, and many scientists believed they had solved the mystery, assuming whales were simply avoiding low-oxygen deserts of the sea. But this assumption would later be challenged, because it failed to explain why some regions with similar oxygen levels were still used by whales, while one specific part of the ocean remained almost completely avoided. When scientists isolated the one region whales avoided more consistently than any other, they were surprised to find that it did not fully match the profile of a classic oxygen-depleted zone, because on paper, its chemistry, depth, and temperature should still allow large marine animals to pass through without serious risk. This area sits far from coastlines, away from heavy shipping lanes, and outside the most intense industrial noise corridors, which eliminates many of the usual explanations tied to human disturbance or environmental collapse. There are no massive underwater mountain ranges blocking migration paths, no extreme pressure anomalies, and no unusual surface conditions that would signal danger to an animal approaching from above, making the avoidance behavior even harder to explain. What researchers did notice, however, was that this region behaves like an acoustic and energetic dead zone, not in the sense that sound disappears, but in the way it becomes unreliable, distorted and inefficient over long distances. For whales that rely on low-frequency calls to navigate and maintain contact across hundreds of kilometers, even small disruptions in how sound travels can create the sensation of disorientation, similar to trying to move through a landscape where echoes arrive late, warped, or from the wrong direction. At the same time, the layered structure of the water creates subtle pressure and density gradients that force whales to expend more energy while diving, surfacing and maintaining neutral buoyancy, increasing metabolic cost without offering enough nutritional reward in return. Individually, none of these factors would be enough to repel an animal capable of crossing entire oceans, but together they form an environment that feels inefficient, confusing and biologically unproductive, triggering avoidance long before physical harm occurs. Still, this explanation left a critical gap, because whales routinely tolerate poor conditions temporarily when migration demands it, pushing through noise, cold and low food availability when necessary. Yet in this specific part of the ocean, avoidance is not occasional or species-specific, but consistent across decades and across multiple types of whales, including those with very different feeding strategies and diving behaviors. That level of agreement suggests that something deeper is at play, something whales are detecting that instruments initially failed to measure. And that realization forced scientists to look beyond oxygen, sound, and energy alone. The real explanation would only emerge when researchers stopped asking what this place lacks and started asking what it contains. The turning point came when researchers stopped treating this region as a passive absence of life and began analyzing it as an active system, because the data hinted that the problem was not that something essential was missing, but that something subtle and persistent was constantly being added. Water samples revealed unusually high concentrations of naturally occurring dissolved compounds released from deep geological sources, including trace metals and reduced chemicals that are harmless in small amounts, but become biologically disruptive when they accumulate over large areas and long periods of time. These compounds do not poison whales directly, and they do not kill fish outright, which is why they went unnoticed for so long, but they interfere with the base of the food web, altering plankton communities in ways that reduce their nutritional value while still keeping them technically alive. This creates a deceptive environment where food exists, but delivers less usable energy, forcing predators to work harder for diminishing returns, a situation that large animals are evolutionarily programmed to avoid whenever possible. At the same time, these chemical conditions affect how seawater conducts sound, subtly changing absorption rates and frequency behavior, which compounds the navigational problems already caused by the layered structure of the water. The reviravolta is this: whales are not avoiding a dead zone, a noisy zone, or a dangerous zone. but a biologically inefficient zone, a place where everything technically functions, yet nothing works well enough to justify the cost of being there. In other words, this part of the ocean is not hostile in the traditional sense, but wasteful, slowly draining energy, clarity and coordination from any large animal that enters it. What makes this discovery unsettling is that whales appear to sense this inefficiency long before humans can measure it, responding not to danger, but to long-term cost, something that only animals shaped by millions of years of migration can reliably detect. This explains why smaller animals still pass through, why ships notice nothing unusual, and why satellites see only empty blue water, while the largest creatures on Earth quietly turn away. And it also raises a far more troubling implication, because this region is not unique in principle, only in scale. When the largest animals on Earth consistently avoid a place that appears normal, functional, and even healthy at the surface, it forces us to reconsider how we define danger in the ocean, because not every threat announces itself through collapse, noise, or destruction. This region is not avoided because it kills, but because it costs too much, quietly draining energy, clarity, and efficiency from any animal large enough to feel the imbalance over long distances and long periods of time. As ocean temperatures rise and circulation patterns continue to change, more areas may begin to resemble this one, not as dead zones, but as low-value zones, places where life can exist, yet struggles to justify staying. For whales, whose survival depends on razor-thin energetic margins across vast migrations, even a small shift in efficiency can redraw routes that have remained stable for thousands of years. What we tend to map as empty blue space can, in reality, function as a barrier, not by blocking movement, but by making passage subtly unprofitable in biological terms. And this reframes the role of whales entirely, because they are not just inhabitants of the ocean, but sensors within it, responding to changes that unfold too slowly, too quietly, for us to notice in real time. If the largest, most resilient animals on the planet are already adjusting their behavior in response to these invisible shifts, then the question is no longer why whales avoid this part of the ocean. The real question is how many other places are changing in the same way, and how long it will take before the rest of the living world is forced to answer that question too. I wish that you enjoyed this spectacular story. Be part of our community by subscribing to this channel. Until the next episode.